Hello, I'm going to walk you through this code and also use the code to solve the puzzle game. So let me quickly introduce the game. The game is known as Wordlink and can be downloaded from Play Store. Currently, it has over 50 million downloads, so it's really, really huge. A lot of people really love the game. So, what's the whole essence of this code? The whole essence of this code is to be able to solve the puzzle. In other words, the code should be able to suggest the words that should be used in filling the boxes right here in the game. So let me just quickly explain what the game is all about. In this game, you'll be given a set of characters. So with this set of characters, you expect to create or construct words that will fill each of these roles. So in this particular example, U and P make up, then CUP can be used to fill the second role. So it's that simple. So for this example, I can connecting A with T will construct the word arts. Then I can link BAT, that's bat. Then to get a third word, then I link T, A, and B. Okay, so these are very, very easy and simple examples. The game gets tougher as we move to higher levels. So in this case, we have IT, and that is it. Then we have IF for if, and then we have FIT for fit. Okay, that's good. So move on to the next level. We have IT and it. We have TIP, which is for Pete. Then we have TIP for tip. Okay, we move on to the next level. We have GO go. We have JOG for jog. Let's move on to the next level. No, we are not going for this for now. Okay, TO, then TOE for toe. So let's now take a look at how to solve this using our program. So now that we understand how the game works, the goal here is to be able to fill in these rows using our program. In other words, we are provided with this set of characters and we have two-letter words. We have two-letter word and a three-letter word row. So let me quickly show you how to solve this puzzle using this code. I will later explain the code in detail, but let's just take a look at a quick example on how to get this thing solved using the code. The first thing you need to do is to run the code, just compile the functions. Then all you need to do is to call solve cross puzzle. Let me include a result variable. Then let me print the result variable. So what do I need to fill here? I need to fill the characters provided, and I can do that in any order. I could start with a D, then followed by A, then followed by M, or I could just use any order, but just provide all the characters given. So here you have to fill the length of each row. So for row 1, I have 2 boxes. For row 2, I have 3 boxes. And that's it. Then you run. Once you click on run, then it produces all the possible words we can use. That's easy. So we have AM arm, We have AM arm, then we have DAM, which is down, but this game doesn't have DAM in its dictionary, so you go for MAD, which is mad. Okay, so the next is SIN. In the first row, we have two-letter words. In the second row, we have two-letter words. In the third row, we have three-letter words. So we run it, so it means we can fill it with IN in, we can fill it with ISEs, we can fill it with INS. It doesn't have that word in the dictionary, so you go with the last option. Okay, so this goes on and on and on. So let's walk through the code. How does this code work? So let's take a look at the code. So this code, actually, we don't need this random any longer because we don't need to shuffle the results. Okay, so let's take a look at the first function. This function simply reads a file containing all the words, all the valid dictionary words that we will be referencing. So we've got words.txt in the same directory as our code. And what this function does is to read this file, words.txt, then it opens the file. It reads a line out of the file. Actually, all the words in the file are, okay, let's take a look at the words. So here we have words.txt, and here we've got all the words. They are all in one line, separated by space. So everything is just in one line, and each word is separated by space. So all we need to do in our code is to read just the first line, then split by space. So once we split by space, we get a list of words. So in other words, we read a line, we read the first line of the file, we split each word in that line by space, and that gives us a list of words. So essentially, the words consist of all the words in our file and in list format. In other words, what is a list of all the words in our dictionary? So we return words, and of course, we don't forget to close our file handle. Okay, the next method simply takes a word and produces a dictionary that contains a letter as character as the key and the number of times the letter occur in that word. So let's take this example. Let's run through some examples. So I'm going to test this map character to show you what it does. So map character, if I provide a word like school, for instance, and I run this, I'm going to get C1, H1, L1, O2, S1. So what does this mean? It means C occurs once, H occurs once, letter L occurs once, letter O occurs twice, and letter S occurs once. So what this map character does is it runs through each character and counts the number of times it occurs in the word. So we get a dictionary at the end, but the dictionary will consist of letters against their count. In other words, in the dictionary, the keys are the letters in the word. The values are the count, the number of times those letters occur in the word provided. So map character simply helps to map a word into a dictionary of character versus its count. So this makes it makes it very efficient in later on. It makes it very easy for us to compare two dictionaries and tell if one is a subset of the other. Okay, so let's take a look at the next method. Okay, the next method is going to return a boolean. So the name of the method is conform word. So what this method is actually doing is it's trying to compare two dictionaries, and it's trying to check if this character dictionary, which is called car map, is trying to check if this car map is a subset of possible car map. So let's say you have a scenario like this. So let's take a look at a scenario like this. So in a scenario like this where we have, let's take a look at a scenario where we have, let's say these are the possible characters provided. Possible character provided. Let's say we've got A, N, M, E. And let's say the current word I'm looking at is A, M. And in this case, let's get the map. So let's get the the map for the first string, which is the map for the possible car. So all we just do is to call map character. So once we call map character, we transform the string into a map of characters. So let's take a look. Let's get that of the word. So I have word. Then what we need to do next is to check if I can form if given MP1, that is the first map, if MP2 is a subset of it. So what happens is if MP2, which is the map for word, if MP2 is a subset of MP1, it returns true. When an event where we have a character that can't be found in possible character means what you have been provided. So in the case of this particular example, the possible character will be ANW. So if I provide a character that does not exist in possible character, then I should get a false, because it means AMI is not a subset of AMNE. So let's check it out. Let's check if it's going to tell us false. Yeah, correct. So the goal of conform word is just to check if I can form this word given this set of characters. So that's what conform word does basically. Okay, so next function is to generate or to get n letter words. So it takes the following input. It takes the entire dictionary as a list of words. Then it takes the possible character as in form of the map form of the possible character. And it takes n. So n is the length of the word that we're interested in constructing. So if I'm interested in constructing 2-letter words, it means n will be 2. And if I'm interested in constructing 5-letter words, then n will be 5. Possible car map is the map transformation of the provided characters. Okay, so let's look into how the code works. So what happens basically is the code runs through each words in the dictionary. Then it checks if the word is n letter. So it checks for the length of the word. If the length of the word is equal to n, then it goes further to check if that word can be constructed or formed from the possible character provided. So if it turns out that I can construct the current word from the possible character provided, then I append to my list of n letter words. So this goes on and on until we run through the entire word. So this code is pretty efficient in the sense that the worst case scenario is for me to run through the length of the dictionary. So if I have, let's say, 50,000 words in my dictionary, so it means I'm going to run through each words in the dictionary. So that's 50,000 times each character in a word. So if the maximum length of the longest word is, let's say, 12, for instance, so it means in the worst case scenario, the computational time will be, the time complexity will be 50,000 times 12. So which is less than a million iterations. So it's really efficient. It's really efficient in the sense that if you have huge number of words in a dictionary, it will still run pretty quickly. Okay. So then the last function is solve word cross puzzle. So this is the function we call to actually solve the puzzle. So what this function does basically is to take in all the possible characters that we're allowed to use. Then it takes in the length of each row. It takes in the length of each row. Each row. So a row is a bunch of boxes, and it means a word. A row is essentially a word we are trying to guess. So, and of course, that's a length. So we are actually guessing a word with a particular length. So the reason why with this star in front of those words is designed is essentially to convert word length into a variable input. In other words, we can provide as many rows as we want, but internally, word length will be treated as an iterable. That is, we can iterate through word length within the code, but the user can provide it as if they are individual input. Okay, so what happens here essentially is this. We convert our possible character into lowercase since our dictionary contain words in lowercase. Okay, the next thing is we transform our possible character into a dictionary of its character. So the next thing is we want to map the word length. Okay, this is what we want to do essentially here. Imagine a case where we have 223 as word length. That is, we have 2-letter words, 2-letter words, and 3-letter words. What we want to do is to count how many 2-letter words that we have and how many 3-letter words and so on. So this length map is just a map of the length of the word versus the number of times it occurs. So that's what length map is essentially taking care of. So that we just know how many, we just know the length of the the words we are interested in and the count, the number of times the number of times it occurs. So in this example, for instance, 2-letter words occur twice and 3-letter words occur once. So next thing is to look over the keys of our length map. The keys will essentially be the unique the number of the length of the word we're interested in, but without repetition. So in this case, our length map will have 2 keys, and the first key will be 2, the second key will be 3. So the 2 means we have 2-letter words. The 3 means we have 3-letter words. So I is just going to be the length of the words that we are interested in. The value obviously will be the number of times it occurs. So in this case, 2 will be the key, but the number of times it occurs is 2. And in this case, 3 will be a key. The number of times 3 occurs will be 1. Okay, so once we loop over the keys of length map, we simply generate I-letter words. So essentially, I is the length of the word. So we simply generate I-letter words. Then we keep doing that until we reach the end of our length map. So this plus notation is a concatenation. So we are simply concatenating what we are currently generating with what we got previously. So once we are done, we simply return our result. So that's basically how the code works. So let's take a look at more examples. Let's test our code with more interesting examples. So we have AMN and we have 223. So let's run this. So obviously we can construct and construct and we can construct man. So let's move on to the next example. I guess this will be more interesting and more challenging. So we have T, E, B, and we have 2-letter word and 3-letter word. So we run this and that gives us B as BE and bet as BET. So we can go on and on and on. So this is just a quick summary of how the code works, and very practical. It solves a very practical game and a well-loved game, and it's really robust. The code has access to over 50,000 words, so which means we'll most likely be able to predict virtually all the puzzle questions, and I believe it's robust enough. Thanks for listening, and thanks for your audience. You have a good one.